Okay, we're going to see about one definition of derivative. The derivative at a single point, at a single value of a function. We've estimated derivative with an equation, or with an expression such as this one, a difference in the y's and a difference in the x's. We call this a difference quotient because it is the quotient between two differences. Yes, you probably recognize that as the formula for the slope between 2 points. So we estimated the derivative by at x equals c by choosing a value of x that was very close to c, and then estimating what is this difference quotient getting close to. But what if we can actually get to c? Well, if we get to c, we would have here c minus c, and that's 0. We can't do that algebraically, except now we do have limits. If we get the limit as x approaches c of the difference quotient, then we would have the exact value of the derivative. In fact, this is the derivative at x equals c. This is it. And we have a symbol for that. The symbol is f prime. The fact that it uses prime, it indicates that it's got some relationship to function f, but it's not exactly the same. It's derived from f, hence the name derivative. But in this case, we have the derivative at c. And this is the definition of the derivative at c. It's the limit as x approaches c of f of x minus f of c over x minus c. We're going to get 1 here. Let's say we have the function f of x equals x squared minus 10x plus 4. And we want the derivative at 3. Okay, the function calls for f of c. The formula calls for f of c. So f of 3 is 3 squared minus 10 times 3 plus 4. And if we operate that, 9 minus 30 plus 4, that's negative 17. So the derivative of f at 3, f prime of 3, is the limit as x approaches 3 of x squared minus 10x plus 4 minus negative 17 over x minus 3. Well, I'll simplify that. 4 plus minus negative 17 is 4 plus 21, so we have this. Of course, if I try to substitute now, got 9 minus 30 plus 21, that's 0 over 0. So we need to work it somehow, in this case by factoring. X squared minus 10x plus 21 can be factored into x minus 7 times x plus 3. So we have that the derivative at 3 is the limit as x approaches 3 of x minus 7 times x minus 3 over x minus 3. These two, of course, cancel. So we have x minus 7, which I can evaluate. 3 minus 7, then that's negative 4. So f prime of 3, the derivative of f at 3, is negative 4. It's very simple. It's just taking one limit. So the derivative is a limit. Well, let's see another one. Let's find g prime of negative 1. In other words, the derivative of g at x equals negative 1 if g of x is x cubed plus 2x squared. So we need g of negative 1. So g of negative 1 is negative 1 cubed plus 2 times negative 1 squared, which is negative 1 plus 2, and that's 1. So the derivative g prime of negative 1 is the limit as x approaches negative 1 of the function x cubed plus 2x squared, here, minus the value 1 over x plus 1. Substituting, this of course is 1, we have it there, minus 1 over negative 1 plus 1, it's 0 over 0. So again, you have to work it. Factoring here, it's quite difficult because we got a cubic function in the numerator. So I'm going to use synthetic division. I'm going to guess that the factor is x plus 1, so I'm going to put -1 here. Remember, it's always the opposite of that value. And then the coefficients, 1x cubed, 2x squared, no x's, and -1. And then when you do the synthetic division, the 1 just comes down. 1 times -1, you multiply, that's -1. You add, 2 plus -1 is 1. And then you multiply, 1 times -1 is -1. And you add, that's -1 here, 0 plus -1. -1 times -1 is 1. And when you add -1 plus 1, that's 0. So here we have this was x cubed, so this is x squared. 1x squared plus x minus 1. So this limit becomes the limit as x approaches -1 of x plus 1, the factor, times x squared plus x minus 1 over x plus 1. These two, of course, cancel. And now I can actually substitute here. -1 squared plus -1 minus 1. That's 1 minus 1 minus 1, that's -1. So the derivative of g at -1 is -1. Okay, graphically, this is the function g. This is what we did. We have the point -1, 1 here. And we have another point x anywhere on the graph, and what we're doing is finding the slope of the point between this one and this one. But we're making this one be very, very close to -1, 1. So if we make it closer, here now we have this line, what we're getting is, instead of a secant line that goes through 2 points, we're getting a tangent line that touches at the point of interest only there. It only touches 1 point there. It doesn't matter that here it will touch it again, but it's tangent at this point. So our derivative is the slope of this line tangent. And that's the geometric interpretation of derivative, the slope of the line tangent. So another way of asking to find the derivative is asking, find the slope of the line tangent. I'm going to do one more. I have it here. The derivative at x equals c is equivalent to the slope of the line tangent at x equals c. So we have the question, find an equation for the line tangent, not just a slope, an equation, to f of x equals -3x squared plus 9x at the point where x equals 2. Okay, first thing you need to find the equation of a line is a point and the slope. We have the x value of the point, or it's given to us, so we need the y value. That's, of course, f of 2. So substituting -3 times 2 squared plus 9 times 2, that's -3 times 4, that's -12, plus 18, that's 6. So the point is 2, 6. Now the slope is the derivative, f prime of 2. That's the slope. That's the limit as x approaches 2 of the function, -3x squared plus 9x, minus the value, -6, over x minus 2, this one. Substituting here, to find it directly, we're lucky, again, you'll get 0 over 0. So you work it. In this case, there's a common factor 3. 3 is the common factor, so I take it out, factor it. That's -3 times the quantity x squared minus 3x plus 2, all over x minus 2. So we factor this trinomial, two numbers whose product is 2 and sum is -3, and we get the limit as x approaches 2 of -3 times x minus 2 times x minus 1 over x minus 2. These, of course, can cancel. And now we can evaluate. Substitute the 2. That's -3 times 2 minus 1, which is -3. The slope is -3, so we have a slope and a point. So in order to write the equation, find an equation for the line, I'm going to use the point slope equation. Y equals the slope, negative 3, times x minus the x of the point, so minus 2, plus the y of the point, which is 6. Summarizing, the derivative at a point is the limit. A limit as x approaches c of the difference quotient. Okay?